Hello? Is good? Yeah. All right. Hello, everyone. Welcome to this talk called Using Events Unit as Smart Contracts. This is going to be a bit of a practical talk. I'm going to be discussing some techniques that you can use in your own smart contract development. Let me start by telling a little bit about myself. So I'm a software engineer at Encode, which is a software consultancy firm in Amsterdam. And we're mainly doing work in the real estate industry. And at Encode, I created a blockchain validated audit trail so that we could make sure that the data inside our applications could be trusted, actually. And I did that as part of my bachelor thesis last year at the University of Amsterdam. Right now, so I'm also a graduate student at the University of Amsterdam. I'm doing a master's in software engineering. And I'm a huge open source advocate. So almost everything we do at Encode is all open source, and we contribute to other open source projects. And a lot of the projects I do on my own are also open source. So last summer I did the Consensus Developer Program, where I developed a decentralized sort of casino app where you can play roulette and maybe win some Ethereum back. And I'm going to be using some of that code as some examples inside this talk. And so this talk is going to discuss the truffle assertions library as well, which is a library that I created specifically to help with the techniques that I'm going to be discussing. So in this talk, I'm going to be talking first about a little bit about what events are, so how they are used and how they are used right now inside regular dApps. And then I will be talking about how events can be used in unit tests, and maybe also what the complications can be when using these events in unit tests. So what are events? Events are mainly a sort of log of smart contract usage. So they allow you to show what's happening in your contract, and in a way that it's not actually stored on the blockchain, but it's stored in the logs of the transaction. And what that means is that they are not accessible to other contracts on the blockchain, because they're not stored on the blockchain, but they can be used very well as a way to communicate between your smart contracts and some off-chain application that you're running. So these events, they have some arguments that you can use, and they also have the option to have index arguments, so that they can easily be searched for in your off-chain application. So how are they used? Like I said, it's mainly to log smart contract functionality, so you can sort of hook into to when your transaction is done. You can see what it has performed. It can be used as a sort of return value for these transactions, because we can't actually access the return values themselves from these transactions. And then it's possible to, for instance, update the user interface with these return values from the events. And we used to be able to do that with like event.watch or event.get, which has been updated to this sort of event emitter interface, which makes everything a bit easier, a bit more fluent, which has been added in Web 3 1.0. And as we can see in this example as well, that we are able to filter only on the events that are emitted for the current player, so for the current account. And we can use that to come to something like this, which is a user interface that shows a list really of all the times someone or the player betted in the app, and what the outcome was, and maybe if they were paid out. So that's one of the things that you can really use these events for. So onto testing. Whenever we're testing our smart contracts, or when we're testing really any software application, it's good to base these tests on the way they actually will be used. So based on the actual application usage. So if you're using these events as a way, for instance, to update your UI, like I showed, then you really do want to test that these events have been emitted or they have not been emitted, or that the values are really correct. And in this testing for a purpose or based on application usage, you can also this can help you to decide whether you want to test with Solidity or with JavaScript. For instance, if you're creating a library contract that should be used by other contracts on the blockchain, then you probably want to be testing that using Solidity, because that's actually the application real-world usage. Whereas if it's really only meant to be used for by an off-chain application like Web3 with Web3.js, for instance, then you might get away with only testing it in JavaScript. But it's always good to test it both ways, because, of course, anyone can interact in any way with the smart contract. So on to these events in unit tests. So why are they not that widely used? What are the complications really to use these events? So the first thing is that it's quite cumbersome to watch for these events inside your unit tests. So you will probably end up doing something like these get first event things. The right one is the old way with Truffle version 4 and Web3 version 0.x. And the other is for the newer API. So what you really want to do is just watch for an event, and then once you get it, you stop watching. But what happens if the event doesn't emit, for instance? Then you just keep on watching in your test, and you keep on watching, and your test doesn't continue. It doesn't fail either, so you just keep on waiting, and you don't also know what your other tests are going to do. And at the same time, Truffle provides these transaction results with, for instance, a log of all the events and their arguments. But these can be a bit difficult or a bit clumsy, at least, to parse. So you'll end up doing something like this. Get me the first log and the name, and then check things with these arguments at the same time. You might also, for instance, if you go a step further, you might create a filter function for your own, for these logs, so you can really check out, for instance, you can filter all the play events and then check that there is at least one. That's already a better way. But the best way is really to just not go through these logs manually. And for that, there's a few different libraries that can really help you with parsing these transaction result logs more easily. And the first one of these is the contract events library, which is pretty nice. You don't really see the letters right now, but it's so that allows you to just more easily parse these transactions and get their arguments and get their event logs more easily. And this can also be used like in regular dApps if you want to be get these events more easily. The second library is the one I created, which is the Truffle assertions library, and this really allows you to make some better assertions about whether a transaction or whether a event has been emitted in a transaction, whether it has not been emitted, and things like that. So we want to look at making these assertions on these emitted events. So with this library, we can, for instance, check that an event has been emitted. So we can do that by saying, okay, we want to have the play event, and you can add a filter function on these arguments. So we can say, okay, well, the player must be the account that we use to bet. And if we win, then, of course, if we expect to win, then the bet number must be equal to the winning number in this case. And we can do some like computations in this function as well. So it's really quite flexible, as they're just like regular JavaScript filter functions. And that means that you can make these filter functions as fine-grained or as coarse-grained as you really want to do yourself. So you can really decide that. And at the same time, you can also check that an event has not been emitted. So for instance, if we are playing our roulette game and the player has lost, or we expect that it has lost, and we must know that it has not been emitted, that a payout event has not been emitted because they lost. So when we can actually test for these events, so we can test that they have been emitted or that they have not been emitted in these transactions, then we can also kind of use these events to our advantage. So we can place them at strategic points inside the function. So we can, for instance, like here, we can check what the balance is before actually transferring money to the winner of a roulette game. And when we do that, we can really we can further specify our test cases. So usually you would, for instance, use a require statement if you always want a certain condition to be true when it's called. But if you just want to test that a condition is true for a specific test case, then you can really use this kind of construction to your advantage. And the final strategy that is that's a really strong strategy to test callback functions. So, for instance, if you're using Oracleize or if you're using a different Oracle service, then they usually come with a callback so that it can reach your smart contract again after they have retrieved some data from off the chain. And of course, if you're creating a dApp, then this function would automatically be called, and then you would have your backend code somewhere set up to handle that, to handle this function call, and probably update your UI in some way. But since your tests are usually kind of like synchronous, so your tests, they execute in order, you can't really expect this function somewhere later, or expect the callback to be called. So what we can do in this case is we can emit an event as well inside this callback function. And by doing that, we can then await this event. So using something like what we saw before, like here, we can get the first event and then get the corresponding logs. And a drawback of this is that it still comes with the same drawbacks that I discussed before. So what if the event doesn't emit? Then you're kind of you don't really know. Then you keep on waiting again. But there's not really a better way right now. So this really at least allows you to test this callback function, and otherwise you wouldn't even be able to test it at all. Then you could retrieve this event, and then with the data from this event, the truffle assertions library allows you to sort of recreate this truffle transaction result object, so that it looks exactly the same as if the function would have been called directly and you would have just gotten back a transaction result. So then we can see here, for instance, in the previous slide, that we are actually using this callback transaction in the rest of our assertions. So just to recap, we've talked about events. We've talked about how they are used. We've talked about that testing should be based on actually real-world usage. And next, we discussed the truffle assertions library. We discussed how it can be used to assert emitted events or not emitted events, strategically placed events to sort of test preconditions. And we discussed testing of callback functions, such as an Oracle callback. That's what I want to leave it at. And if you have any questions regarding these techniques, or if you have any other ideas on how events might be used inside your own unit tests, yeah.
You told about testing preconditions on your smart contract.
Yeah.
With events, but yeah, it will cost extra gas, right, to emit more events? Is that a drawback or a problem? Or?
Yeah, that's definitely a drawback. So something that could be done as well is some other pattern that you can use is sort of overriding or overloading your functions in a special testing contract, and then only add those events inside that contract, or you would have to sort of like manually get it out before deployment. So yeah, it's definitely not ideal in that way. But it's yeah. So.
Okay, thank you.
We got time for maybe one or two more.
All right, thank you for your attention.